Good afternoon. I'm Prasad. I'm CTO and co-founder of Okahu AI. I'm also the maintainer and on the steering committee of Project Monocle. And I'm going to talk about that project, as well as overall the whole exploding landscape of GenAI applications, and what are the challenges in monitoring that, and how Project Monocle helps you address some part of those. Okay, so the agenda, I'll talk about the GenAI landscape. What are the applications? What are the challenges? How they're different from the, the application that people have been monitoring today with web-based or database-based. I'll show a couple of examples, a simple chatbots and a team-based chatbot, and then talk about why that monitoring is so different and how Monocle helps you address some of those challenges. We'll use a couple of demos against those same application, how easy it is to generate traces using Monocle, and talk about more details of that project, and of course, beyond the tracing, what else can be done for that overall monitoring solution. So let's get started. So how many people here have played with GenAI applications or deployed something in production? All right. So as you're mostly aware, there are a few of these popular design patterns how people use in GenAI. You have these copilots that helps you, complete things in the product that you're using, a better way to interact that product. You have bots where a human can interact with that system and get a lot of answers or those problems addressed. And then you have all sorts of agentic workflows, which are sort of your action engines, if you will, that beyond giving a simple answer, they can perform actions on which you are asking the questions. And then on the right side, you have a different set of technologies that are out there. You have a number of SDKs and language frameworks that help you build these applications. Like all the cloud providers, they all have their different inference provider, model hosting and model serving. Like you have Google Gemini and Azure OpenAI or OpenAI, and their corresponding SDKs that you will use in your application to interact with those models. And those models are hosted, could be on the cloud provider service, like Gemini or OpenAI, or you could be hosting them themselves on something like, say, NVIDIA Triton or a Azure OpenAI. So there's a whole hybrid approach of how the applications are developed, how the models are hosted, and the inferences are served. And that makes the way to monitor those different applications and have a consistent way of generating the traces a big challenge. And this landscape is just growing every day. You read news about new kind of agent frameworks or SDKs that are being available in the field today, and the whole thing has become a big challenge. And in a large setup, you will always have people trying out different things in the prototype and going to production. So being able to monitor a hybrid application layout and across different applications is a big challenge today. So I'm going to show a couple of examples of very representative GenAI applications. I hope this will work, because people are having some technical challenges switching back and forth. OK. Is it readable? Cool. OK, so the first example here, no, actually, let's go back to a simpler one first. OK, this is a very simple chatbot. It has some coffee-related data downloaded from Wikipedia. And you can ask questions about coffee, and it gives you answers. So it's a Python application. Okay, so let me run this. It's using OpenAI in the backend to interact with the GPT-4o mini model. So let's say, what is an Americano? And it gives you some answer based on that Wikipedia. This is one of those RAG pattern, retrieval augmented generation. So the data I have is what I pass to the model and says, you are a coffee agent, and answer your questions based on this data and not the rest of your knowledge. So if I ask for something like, what is beer, it says I don't know, because that's my prompt. I have instructed model only to focus its answers based on the context that I have provided. So this is a classic simple chatbot where you would deploy something like this for a customer portal where people ask questions about your product, and they get the answers from your, let's say, product manual. Then here is another example, it's a little more advanced. So this is a chatbot based on Microsoft Teams. I can show you. Here is the real one that's deployed in the production in our Teams. But this one here is a developer simulator. That's what you'll use to actually code this bot and then deploy it in production. So this one has a prompt that says, you're like a funny Monocle bot, and you want to answer questions about OpenTelemetry. So let's run this. Okay. Then I'll ask, let's say, how's the portal conference going? I'd give some funny answer. This is using the Azure OpenAI, and the same, I think, GPT-4o model hosted in our cloud in Azure OpenAI. So these are the two examples. They're both using different technology components. One is using LangChain with, as a language framework for application, talking to OpenAI. The other one is using Teams SDK, talking to Azure OpenAI, hosted in Azure. So if I have to instrument both these applications and want to look at the traces and see what's going on, the challenge for me is to instrument all of these technologies. And if I switch from tomorrow, let's say, LangChain to Llama Index for my language framework, I have to redo all of that on top of my OpenTelemetry. There's a lot of last mile do-it-yourself work that I need to do today if I have to trace GenAI. And that is the problem we're trying to solve in Monocle. So let's go back. So as I was saying, why it is different? Because of all the brand new technology components. Secondly, in a typical GenAI application, there are three things you have to worry about. You have your code, you have your prompts, and you have the model. So when the application is performing correct or not, it's really all depend on how you're prompting it, and you want to change that, or iterate on that prompt. And at some point, you might think the model that you're using is not the right choice, and you want to experiment by changing that model. So it's really those three factors that you want to iterate upon to take your application from your laptop to pre-prod to prod. And that means when you're monitoring it, and even in the production, what you really want to know is how those factors are behaving, and if you change something, how is that impacting? Like, what are the prompts I'm passing? What are the responses I'm getting against one model versus different? So what is the right combination I want to put it in there? And also, like, how much money I'm spending on a, let's say, a hosted model like GPT-4o mini versus GPT-4o. I get better answers, but I get more charged for that. What is the right option for me? And as I said, lastly, it's a very highly evolving ecosystem. So many new things are coming up. So it's always you have to spend a lot of time in instrumenting as opposed to actually understanding that product and building your solution with that. So that's why we introduced Monocle late last year. We started this as a closed source project and then took it to Linux Foundation Data and AI. So as I said, it's a community-driven open source project. The goal is to make it as low last mile coding possible with a simple dropping of your library. It's built on top of OpenTelemetry. It follows the same OpenTelemetry standard in terms of its spans and traces. It's very, very focused on GenAI. That's the goal, is to make people building GenAI application easier to do the instrumentation with little effort. So I'm going to go back to my two demo applications and see how easy it is to instrument them and get the traces out of them. So, OK, let me stop this guy. Kill this. Let's start first with the simple bot. So all I'm going to do is install my Monocle Python SDK. And then I'm going to go back to my previous command line, and I'm run it with the Monocle wrapper. Let's ask the same question. What is that? Kano. Okay, got the answer back, and let's look at my files. And this has generated a trace file, which is OpenTelemetry compatible. And it has captured the specific spans which are relevant to GenAI. Like, for example, this is a retrieval span when it's dealing with a vector database using the Chroma DB vector store. It's using this as an embedding model, and what was the prompt passed to the vector store and what the context is retrieved. What is the, let's go down here. The interaction with the actual, sorry, the interaction with the actual model, what prompt I sent and what response I got back. To make the things even simpler, there is a Visual Studio Code extension for Monocle. I've already installed on this, so which makes the instrumentation and reviewing a lot simpler. So if I go back to my trace file, within my IDE itself, I go to the Monocle option and look at the trace timeline. And I see a simple, a trace timeline viewer. I can select one of them, let's say this guy, and it shows me the details. What was the prompt and response and the tokens information, et cetera. I can go back to the top of the trace where the API was called, and I click on this, and it will take me to the source code from where this API is called. So it makes it a lot easier as a developer to integrate this into your development environment. You're debugging things, you're experimenting things in your new application. You see the traces coming out and work with it. Let's look at the other example, which is the team spot. Typical development cycle is I'll test this in my simulated environment, and then I'll go deploy this into my Teams environment, so I can actually go to my Microsoft Teams application and interact with this bot. So for that, I'll need to add some API code here because I'm not going to run it as a Python wrapper. So the Monocle Teams extension let me make that very easy. So all I have to do is enable Monocle. And it has introduced the required import and the API call. It also added my extension requirement in my requirement, and it installed the library. So now this code is working. So I'm going to rerun this application. Just to ask one more question. And then it's behaving the way the prompt is. Now let's go back here, and we'll wait for the traces to come back. Oh, I'm sorry. Actually, let me stop. Instead of putting it in the console, yeah, let's go. It's a little bit harder to see. By default, it's put it in the console. So if you're running this in the web mode, you can see all this in your console. But for this, let's change this to a file. I'm going to run this again so we can see the files being generated. Simple message. says good afternoon. All right, and now I've got my trace files here. And let's go visualize this with the viewer again. Okay, and then I see the details of what is the interaction at that particular span, what prompt I sent to that model. So as I was mentioning, the objective was to make this as simple as possible for the application developers. The heavy lifting of how those SDKs work, what are the relevant spans, et cetera, is taken care by the Monocle community. All you need to do is just drop it in, and that too through a IDE extension makes it fairly straightforward. Okay, so just to recap, what is Monocle? For first, it's a spec that extends OpenTelemetry. It defines the namespace. It defines the types of spans that are relevant in the GenAI space. It's an implementation of that spec. There's a Python SDK and there's a TypeScript SDK, which are the two most popular languages that are used for GenAI applications today. And this is a community-driven open source project under the Linux Foundation. So why Monocle? For one, it's built specifically for GenAI. I mean, if you're doing something else, that's not the right choice. But for building GenAI application, it is really tailor-made for that. The consistent format is the really most important thing that it brings. It defines the model, what are the known operations in the GenAI application technology, and how they should be described consistently across different language components, different service providers. So you get a consistent formatted traces. So whatever the downstream processing that you're doing to analyze it, to aggregate it, makes it straightforward across different application space. The goal is to make it as little as possible impact on the application. You can run it literally with no code change in your app or very little changes to get those relevant traces that you can then later analyze. It's highly extensible. It's built on top of OpenTelemetry. You can add new things that is not provided by the open source community out of the box if you choose to do so. And then the traces that are generated, you can always store it locally. Monocle provides the out-of-the-box connectors to cloud stores. So you can send it to, let's say, S3 or Azure Blob Store, or you can send it to a Monocle-compatible processing like Okahu AI, and I'll just briefly talk about that. The concepts are very similar. The traces and span are exactly the OpenTelemetry concepts. So are the exporters. And as I mentioned, the S3 and blob connectors are supported out of the box. The meta model is really what Monocle brings it as a spec. It has defined a sort of an opinionated approach of what are these GenAI operations, and how do you, what is that namespace? How do you define those entities like models, the inference providers, cloud providers, et cetera? And a standardized ways to generate that form. Like if there is an inference span, then you should have the attribute section that lists the models, whereas in the event section, it will list the prompt and the response that is coming back from it. And it will be consistent across different SDKs or different providers. And the scopes is, lastly, you want to go beyond a single trace. Let's say that chatbot, I have a conversation. Every top-level API is going to generate a trace, but I'm really interested in stitching all those traces together to understand how my conversation is going, how long the conversation took, how much prompts I spend, like how much it's going to cost me. Or let's say I can put it to another LLM and say, analyze the sentiment of this conversation. Was the end user happy or not? So I want to get how do I stitch that conversation together? So Monocle has this notion of scopes, that it's a unique ID that goes across the traces. And you can generate them either programmatically by annotating the code, or it can also get it declaratively. Let's say you have a web application that sending a session ID, you can just configure a property in the Monocle runtime configuration to catch that ID as a scope, and that gets percolated in your traces, and it's available for you to analyze it. And lastly, going beyond the traces are great for your initial troubleshooting. You want to do the aggregations on top of that to understand how things are happening, like, what are your KPIs, like how much the application cost, how much is the success ratio, what is the user sentiment, etc. So you want to aggregate those traces, combine them together, and run different analytics and insights. So today, you can store those traces locally or in the cloud store. Any OpenTelemetry compatible service can consume it, and you can probably build your own aggregation queries on top of that. Or there is Okahu AI, which is fully compatible with Monocle and can directly natively run analytics on that. I can show, I guess I'm almost out of time. I'll just show a quick demo of that. So this is the my team's production application for last. Sorry about that. Okay, that wasn't an intended effect for the Okahu page. It was an accidental one. So in this case, it's showing me that, like, there was a lot of. Oh. Like almost 99% in my case are like pings coming from my bot, whereas like only 30 interesting conversations that happened in the last 14 days. I can go look at the breakdown, like how many errors happened, how many completion happened. I can go drill down to the error, and go look at the prompts, why those errors happened. So all this is coming from my telemetry of that, what Monocle is sending. Like in this case, it's saying there is an error because I had, Azure OpenAI is throttling me, or maybe in some case, let's say here, this is a guardrail on Azure OpenAI that tripped because I probably used some bad language here. So with the traces, you can then collect it and build all these analytics to understand your KPIs and come back and do the troubleshooting. So with that, I'll just put my last call of action. Monocle, as I mentioned, is a community-driven open source project for GenAI application monitoring. Please give it a try. You can just download it via the PyPy or the NPM for the Python and TypeScript SDK. Give us your feedback. If you want to contribute to the open source community, we'll be very happy to onboard you.